welcome to Pi Day. My name is Ruhi Sood and I am a product manager with Amazon S3 Glacier. Today, I'll be talking to you about putting cold data to work for AI and ML workloads with Amazon S3 Glacier. If you are a data scientist, a machine learning engineer, a storage admin, or are simply looking to minimize the storage costs of your valuable cold data while keeping it accessible, this session is for you. Let's get started. I've divided this session into four parts for us. We'll start by talking about the importance of having a cold data management strategy and the challenges that our customers face in putting the cold data to work. We'll then move on to explore ways to unlock the value of your archive data using Amazon S3 Glacier. Finally, we'll talk about using Amazon S3 Glacier for storing and training AI and ML workloads. So, first of all, why is it so important to have a cold data management strategy? Consider this. In 2022, the world crossed almost 100 zettabytes of data created and replicated for the first time. Most organizations today are experiencing an exponential growth in their data from everyday logs, mobiles, sensors, vehicle information, even surveillance data. Don't be surprised if your organization is also generating more data than ever before. It is very likely that most of you are storing terabytes, if not petabytes, of data. Now, combine this with the fact that most of the world's data is cold. Most of you would agree that data gets cold very, very quickly, sometimes as soon as 60 or 90 days. Does that make you wonder how much cold data your organization has? Well, leading industry reports suggest that anything between 60 to 80% of the world's data is cold. So likely most of your data in your organization is cold too. And at AWS, we firmly believe that all of this cold or archive data is just data that is not in use at the moment, but our customers have told us that their data is unique and valuable and they're keeping it around because they have plans to monetize it. And one of the most cited use cases today is to use cold data for driving machine learning models. Machine learning is now making an impact across every industry: healthcare, manufacturing, financial services, retail, media and entertainment, you name it. And customers across these industries are using this vast amount of data to create decision logics or training models to improve patient outcomes, optimize supply chains in retail, detect fraud in financial services, for example, personalize products or even launch new products in retail, and accelerate content creation and even increase user engagement in media and entertainment. In fact, a Deloitte report suggests that over 94% of the business leaders think that artificial intelligence is critical to their success. So you would ask, what's the challenge with putting all of this cold data to work? There are two primary challenges that our customers face when managing cold data. The first question that we often hear is, where can I store the petabytes of my data at low cost? Customers today are generating lots of valuable data, and they want to reduce the cost of storing their aging data sets. The next question that our customers ask: how can I access cold data to meet my analytical needs? Now, this is an equally important challenge. Customers want easy access to the data to meet their artificial intelligence and machine learning needs. Now let's talk about how you can overcome these challenges and unlock the value in archive data using Amazon S3 Glacier storage classes. To provide our customers a secure place to store all of this cold data, Amazon S3 offers three purpose-built storage classes where you can store your data in an economical manner. Storage costs range from 0.4 of a cent per gig with Glacier Instant Retrieval to just under $1 per terabyte per month with Glacier Deep Archive. You also have a choice in retrieval times. For example, with Glacier Instant Retrieval, you get millisecond access. It is designed for rarely accessed data that still needs immediate access. Ideal for performance-sensitive use cases like image hosting and news media assets. Glacier Flexible Retrieval with retrieval options from minutes to hours is another option. It is an ideal storage class for archive data that does not require immediate access but needs the flexibility to retrieve large sets of data multiple times a year. And finally, we offer Glacier Deep Archive, which is the lowest cost storage at $1 per terabyte month and retrievals within 12 to 48 hours. It is designed for customers, particularly those in financial services, healthcare, media, even public sector who need to store data sets for 7 to 10 years for regulatory and compliance needs. So, what's the right storage class for my workload? Is your next question. For machine learning use cases where you're retrieving data only a few times a year but you have large data sets, Glacier Flexible Retrieval and Glacier Deep Archive are powerful archive storage options that allow you to access your objects in a cost friendly manner. Finally, Amazon S3 also offers intelligent tiering that helps you to minimize your costs by automatically archiving objects based on the last access date. Now, this is best suited if you do not know the access patterns of your objects to determine when an object becomes cold. Remember, objects archived in intelligent tiering have no retrieval fee, but these do become warm upon access and they stay in the warmer storage classes until they are ready to be tiered down again. Let's consider an example to see how much you can save by moving archive data to Amazon S3 Glacier. Let's say you want to store about 10 petabytes of transcripts or customer interaction data for training chatbots. This data is saved for multiple years, has an average object size of, say, 10 megabytes, and is infrequently accessed. This customer can save about $2 million a year in storage costs by moving this workload to Glacier Deep Archive. Remember, though, there is a transition fee that applies when you move objects from hotter storage classes to colder storage classes. So always optimize by using large size objects. In this case, with approximately a billion objects, there is a transition cost of about $53,000. Some of our customers who have benefited from these low cost archive tiers includes NASA that almost doubled their storage while reducing their object storage cost by 51% through a shift to S3 standard infrequent access and S3 Glacier Deep Archive for storing several years of Earth-sized data from their spacecrafts. Now that we have discussed low-cost storage options, that brings me to our second challenge: how to access all of this code data. The most common way to access data in Amazon S3 is to use the GetObject API. For asynchronous storage classes like Glacier Flexible Retrieval and Glacier Deep Archive, you will first need to call the Restore API. Now, our customers have used these access options and restored more than 1 petabyte of data per day from S3 Glacier Flexible Retrieval and S3 Glacier Deep Archive. Even though this data is cold, our customers are finding ways to create value with their archive data every single day. And we are delighted to support you in your archive and retrieval journey. We recently launched a 10x restore throughput increase, resulting in up to 90% faster retrievals from Amazon S3 Glacier Flexible Retrieval and Deep Archive storage classes. If you are currently using Amazon S3 Glacier storage classes, you are already benefiting from this restore performance improvement at no cost to you. Let's take an example to see what this 10x restore improvement means to you and how you can leverage it. Let's say you're a financial organization and you want access to 10 million objects across 100 terabytes of data for forecasting and demand data. At 1000 TPS, you can submit the 10 million requests in just under 3 hours. Using standard restores from Glacier Flexible Retrieval, you can complete all of the restores in about 6 hours, including the 3 hours to submit the requests. Using bulk restores from Glacier Flexible Retrieval, you can complete all the restores in about 5 to 12 hours, all for free. Once you have restored the data, you can use this to train your machine learning models. You pay for the storage at S3 standard rates for the number of days for which the data was restored. Now, let's say you have finished training your model early. You can always update the restoration period by reissuing the restore request with a new period. We love how our customers put these capabilities to maximum use. Our customer Capital One moved a major portion of their old version data to S3 Glacier and S3 Glacier Deep Archive. Using this recent restore performance improvement, they've been successful in restoring millions of objects in a single day, all free of cost. We have talked through some options on low cost storage and restore from Amazon S3 Glacier. Now, let me walk you through some examples that demonstrate how you can use cold data in Amazon S3 Glacier for analytical and machine learning purposes. I want to start by sharing this inspiring and powerful feedback from our customer Ancestry. A little bit on Ancestry's background. Founded in 1983, Ancestry operates a large network of genealogical, historical records, and related genetic and genealogy websites. Ancestry has over 30 billion records in its online database and has more than 3.5 million users. Now, Ancestry here is setting a really high bar using artificial intelligence for handwriting recognition in their models. They archived high quality digital images in Amazon S3 Glacier and restored hundreds of terabytes of these high quality images from Amazon S3 Glacier within hours instead of days to train their cutting edge handwriting recognition AI models. Customer feedback like this inspires us to innovate every single day. To take this a step further, let me walk you through an end-to-end workflow to demonstrate how you can put your cold data to work. Now, let's say you are an autonomous vehicle corporation archiving millions of vehicle objects related to vehicle sensor data. You train machine learning models all year long, but few times a year you want to go back and gather, let's say, 100 terabytes of your cold data to train your model or to apply a model to it. Here's a sample end-to-end strategy on how you can integrate your cold data storage to analytical services. In this example, you can create a data lake in Amazon S3 and archive colder data sets to Amazon S3 Glacier. Now you can integrate it with services like AWS Glue to run analytics using machine learning services like Amazon SageMaker. Let's double click on how you can restore the data from Amazon S3 Glacier so you can run analytics and use it for machine learning. Now, there are 3 steps to conducting a successful restore of cold data cost effectively. The first and the most important step here is identifying the list of objects that you want to restore. Amazon S3 inventory is a great place to start. It allows you to generate a list of objects and metadata such as object size, storage class, last modified date, etc. that you can use to filter down on your restore targets. Now, let's say in our example, the Autonomous Vehicle Corporation identified that 10 million objects need to be restored based on using Amazon S3 inventory. Now, once you have identified the list of objects, keys, and versions that you want to restore, you can use Amazon S3 batch operations to initiate a restore from Amazon S3 Glacier, Flexible Retrieval, and Deep Archive storage classes. In our example, Autonomous Vehicle Corporation could use bulk restore within Amazon S3 Glacier Flexible Retrieval to initiate the restores for these 10 million objects that they identified, all for free. Next, they may use the batch operations to initiate restore for all objects, optimizing the request speed. Finally, they may configure restore events in EventBridge to trigger Lambda on restore events. Now, with this setup, restore requests are going as fast as possible. Lambda functions are processing the data as soon as it's ready. Automatic retries are happening and a completion report is provided, which means that you can ensure all of your restore object requests have been successfully submitted. So in summary, using batch operation here allows you to get the highest possible TPS restore from Amazon S3 Glacier, especially when you have millions and billions of data. With bulk restore, Autonomous Vehicle Corporation can actually complete the restore within 5 to 12 hours. And now that your data is restored, it's ready for use. You can either feed this data to your machine learning model, or you can run services like Athena after copying the data to S3 standard. In our example, Autonomous Vehicle Corporation may want to curate this data first, so they can copy this. So they copy the data into S3 standard storage class using the copy function. And now they can use Athena on top of this data and then feed the curated data set to their machine learning models. This is an example of how you can cost effectively manage petabytes of archive data and still put it to use to gather valuable insights for your organizations. Here are the key takeaways from this session. As you define your cold data management strategy with Amazon S3, consider how many times you want to retrieve the data to select the right archive storage class. Glacier Instant Retrieval works best for performance-sensitive workloads with immediate access needs. Glacier Deep Archive is ideal when you need to restore data no more than a few times a year. And Glacier Flexible Retrieval is better when you want a free restore option for potentially more frequent and large restores. Intelligent tiering is useful when you want to automatically save costs on your data while requiring no application changes. Always prefer large size objects as restore performance is best for large size objects. You could consider creating Parquet or similar files to optimize processing of data once the restore begins. Next, leverage automatic retries and management controls using S3 batch operations to initiate restores at 1,000 transactions per second. Maximize the cost savings by using an object size filter of at least 128 KB when you move objects from hotter storage classes to colder storage classes. And last but not the least, leverage automated notifications to trigger events once your restores have completed from Amazon S3 Glacier storage classes. So now it's time for you to put your cold data to use. I'm excited about the valuable insights that you will gather for your organization as you put your cold data to use. Thank you for joining me today. Have a great rest of your day.